Hello, and welcome to The Space Above Us, Episode 10, X-15, Flight 90. Last time, we took a look back and bade a fond farewell to Project Mercury, NASA's first manned space program. Typically at this point, a history of NASA human spaceflight would move on to Project Gemini, but we're going to be doing something a little different. Before NASA was NASA, and before brave men began riding ballistic missiles into orbit, a series of groundbreaking experimental aircraft were being developed in the California desert. These experimental planes, or X-planes for short, were typically a combined effort of the U.S. military, mostly the Air Force, and first the NACA, NASA's predecessor, and then NASA itself. These were not airplanes being developed for use in combat, or in reconnaissance, or in commercial operation. They were designed, built, and flown to explore the unknown realms of high-performance flight through Earth's atmosphere and beyond. The first was the X-1, which became the first aircraft to exceed the speed of sound in level controlled flight, when piloted by Chuck Yeager on October 14, 1947. It was followed by the X-2, which flew up to Mach 3, the X-3, which helped examine sustained supersonic flight, the X-4, a tailless airplane, the X-5, which sported movable wings that changed their angle with respect to the fuselage, and so on. Each of these aircraft expanded the envelope of human knowledge about aeronautics with their own specialized contributions. The subject of this episode and the next will be the X-15, an aircraft, an occasional spacecraft, designed to explore the hypersonic regime of flight. When I started this podcast, I did so partially to share my love of all things space with anyone who was willing to listen. But my not-so-secret real goal was to learn more about these fascinating spacecraft, pilots, and missions myself, just to satisfy my own curiosity. When I started my research and began defining the parameters of the show, I recalled something about a few X-15 flights flying high enough to be considered space flights, but I didn't really know much about it. I did a quick fact check and saw that sure enough, 2 flights passed the internationally recognized 100-kilometer altitude required for spaceflight. 11 additional flights passed the U.S. Air Force requirement of 50 miles, or just over 80 kilometers. Okay, sounds good to me, I thought, and announced my intention to cover those flights in the introductory episode, then mostly forgot about them. As Project Mercury came to a close, and I began reading ahead, I started to learn more about the X-15, and I have to say, I regret not learning more about this remarkable vehicle sooner. I learned that the X-15 was essentially a second parallel space program, separate from the brilliant spotlight accompanying Project Mercury, quietly doing its own thing high above the southwest United States. Flights 90 and 91 of the X-15 crossed the Kármán line, that magic 100-kilometer high boundary. The plan is to talk about those 2 flights during this episode and the next, while attempting to squeeze in a lot of other information about the development and operations of the X-15. And while they won't get their own episodes, I plan on briefly covering the other 11 flights that surpassed 50 miles in altitude and were arguably just as much space flights as the other 2. With that said, let's get into it so I can explain why the X-15 has me so excited, and while there's at least 1, and perhaps 7, more astronauts than you thought. The contract for the X-15 aircraft was awarded to North American Aviation in 1955, and the contract for the rocket engine that would power it was awarded to Reaction Motors in 1956. It's interesting to note that X-15 development predates the flight of Sputnik, the creation of NASA, and the beginning of development on Project Mercury. The vehicle was intended to take the next step up from the Mach 3 speeds currently being researched and investigate the hypersonic flight regime, which roughly corresponds to atmospheric flight faster than Mach 5, or 5 times the speed of sound, and above. Once you get going at these speeds, which is around 4,000 miles per hour, the aircraft begins to experience new troubling phenomenon, particularly thermal heating. The X-15's job was to fly at the extreme altitudes and velocities required to explore this flight regime, to help validate and tweak existing aerodynamic theory, and to make new discoveries along the way. I admired the early X-planes because they were so pure. Hey, we need to know what happens when you fly at 4,000 miles per hour. Alright, let's go do that. The aircraft was ready to fly by June 1959, but the rocket engine that was to power it was not. The XLR-99 engine was a real engineering marvel. It was capable of 60,000 pounds of thrust, multiple restarts in the air, and could throttle down to as low as 18,000 pounds of thrust, 30% its maximum value. This may not seem like a big deal, but let me be clear, this is a big deal. Rocket engines are extremely simple, but extremely temperamental. They like to work in one particular way and don't want to do anything else. They're also tricky to get going in the first place. The fact that the XLR-99 could not only restart multiple times, but throttle down to such deep levels was impressive, and it was the first sizable rocket engine to be able to do so. But all of that resulted in an incredibly difficult development process. The XLR-99 was delayed multiple times, cost orders of magnitude more than expected, and would not fly on the X-15 until late 1960, almost a year and a half after the aircraft was ready. For the first 25 flights of the X-15, and several afterwards, the aircraft was powered by two XLR-11 rocket engines. The XLR-11 was another product of reaction motors, and was used to power the X-1 through the sound barrier. The XLR-11 left the X-15 woefully underpowered, but it at least allowed for test flights and some early operations while the XLR-99 was getting the bugs worked out. So that covers the engine, but what about the aircraft itself? The vehicle was about 50 feet long and had a wingspan of about 22 feet. One of its unusual features that is likely to strike the observer first is its tail. When you're going extremely fast in extremely thin air, it's important to have rock-solid directional stability, and the X-15 tail provided it. The tail itself was a thick wedge shape, which helped the pilot maintain control at high speeds. It also extended below the vehicle, which, when combined with the horizontal stabilizer, gave the rear of the aircraft the appearance of an arrow with feathers at the back. The lower tail fin was so low that it actually extended past the landing gear and had to be jettisoned before landing. But don't worry, recyclers. The discarded ventral fin would land under a parachute and be recovered for use on future flights. The skin of the X-15 was made out of the exotic metal alloy Inconel X, which is known for its extreme heat resistance. This was required to combat the massive amount of heat the aircraft would encounter as it flew through the atmosphere at high speed, just like a re-entering space capsule. The structure of the wings had to allow for a certain amount of expansion of the exterior skin as well as the interior support structure. Any small snag in the skin would cause a hypersonic vortex that would quickly begin melting even the mighty Inconel X. Over the years of the program, the X-15 would develop ripples and bumps that had to be smoothed out due to the intense thermal cycles it experienced at high speed. But if the X-15 looked weird on the outside, it was nothing compared to the inside. The aircraft has been compared to a flying gas tank, since an unusually large amount of the interior volume was taken up by the rocket fuel and oxidizer required to power the engine. To help save weight, the propellant tanks themselves became an important part of the structure of the aircraft. The exterior skin of the propellant tanks was the exterior skin of the vehicle itself. The pilot sat up front in a cockpit filled entirely with nitrogen to reduce the likelihood of fire as the vehicle heated up. This meant that he was unable to open his faceplate to scratch his nose once inside the cockpit, though some pilots held their breath and took their chances. The aircraft was controlled by a traditional center control stick as well as a new side control stick. This was introduced to allow the pilot to more easily maintain control while enduring the G-forces of launch and entry of the aircraft. In two of the three X-15s, there was a third stick on the left side of the cockpit, which was used to activate a reaction control system, just like on a spacecraft, as the X-15 left the upper atmosphere. On the third vehicle, an advanced control system seamlessly blended the traditional air-based controls and the advanced new reaction controls on one control stick. I should also mention that the X-15 was actually the first vehicle to use such a reaction control system in a space-like environment, beating Mercury to that particular milestone. Further ahead of the pilot was the instrument package in the nose of the aircraft. Normally you would see an array of instruments sticking straight out of the front, but these would melt in no time in the extreme heat generated during flight. Instead, the X-15 employed a special ball nose instrument. It measured various parameters about the flight and could be rotated to adjust for the changes in angle of attack. Since it would take the brunt of the heat, it was cooled by liquid nitrogen. The X-15 was created to validate theoretical models developed with the aid of hypersonic wind tunnels. With this in mind, each flight set out to answer specific questions. For instance, A flight might call for the pilot to maintain a certain level of heating of the aircraft in order to study the reaction of the Inconel skin. Another flight might call for the pilot to soar to unprecedented heights in order to determine the level of heating that could be expected on re-entry. Somewhat ironically, the X-15 proved that the wind tunnel tests were so accurate that there was a reduced demand for X-planes afterwards. While there were experimental aircraft to come, large-scale research airplane programs like the X-15 have largely fallen by the wayside. X-15 operations mostly consisted of two types of flight, high speed or high altitude. Since we'll be talking about a high altitude flight today, allow me to first quickly explain how a high speed flight would typically work. Both types of flights would begin in the same way. First, all flights began at Armstrong Flight Research Center, a NASA field center at Edwards Air Force Base. The center was previously known as the Dryden Flight Research Center, and at the time it was known as the High Speed Flight Center. The X-15 would be mounted to the underside of the right wing of a B-52 bomber, which had been modified for the program. The mount included a connection to the X-15 liquid oxygen tank, which allowed the B-52 to replenish the oxygen that boiled off before the start of the mission. The mount also included an intercom line, which allowed private communication between the B-52 and the X-15 pilot before launch. The B-52 would take off, fly up to around 45,000 feet, and the X-15 pilot would drop his vehicle from the wing. At that moment, the pilot really had his hands full because he had to start the rocket engine as quickly as possible while also correcting any attitude changes caused by departing the B-52. Once the engine lit, the high-speed and high-altitude flights would diverge. On a high-speed flight, the pilot would fly up to an altitude of around 100,000 feet, about 20 miles, and then level off while leaving the rocket engine firing. He would increase the angle of attack while maintaining level flight as the engine pushed the aircraft to the truly staggering speed of 4,000 miles per hour, 6 times faster than the speed of sound. The fastest speed attained in the X-15 was over 4,500 miles per hour, Mach 6.7, in the second X-15, which was coated in a special protective ablative material for that flight. But today we're not talking about a high-speed flight, we're talking about a high-altitude flight, and specifically Flight 90, flown by test pilot Joe Walker. Joe Walker was born on February 20th, 1921, and had been flying all sorts of strange aircraft more or less ever since. He was involved in a number of early X-planes as well as development for fighter jets and bombers. He was also the first pilot of the LLRV, the Lunar Landing Research Vehicle, otherwise known as the Flying Bedstead due to its strange spindly appearance, which the Apollo astronauts would fly to help get a feel for what landing the LEM on the moon would be like. Joe participated in the X-15 program as one of the NASA pilots, alongside fellow pilots from the Air Force and Navy. Joe was one of the more senior research pilots flying the X-15, and thus was tasked with some of the more tricky flights, including the 2 highest flights and the 3rd fastest. On July 19, 1963, Joe Walker could be found donning his silvery spacesuit and preparing for an extreme high-altitude flight in the X-15. The flight was to take place a mere 2 months after the final flight in Project Mercury, Faith 7, which is lucky for me since it would have made the structure of the podcast a whole lot more complicated to have 2 overlapping programs. As usual, the X-15 was slung under the wing of the B-52 mothership. Its fuel tanks were filled with anhydrous ammonia, and its oxidizer tanks were filled with liquid oxygen. This is just me speculating, but from what I know of the X-15, it must have been quite a sight to see as final preparations were being made before a launch. The aircraft itself is a dark and vaguely menacing shape hanging from the enormous silver B-52. Oxygen vapor clouds would have been swirling around both vehicles, and mist would have been drifting off of frosty patches of the X-15 where the oxidizer tanks were placed. The area would be surrounded by the pungent odor of the 100% pure ammonia used as fuel. And then, as engineers made final checks and preparations, a man in a silver spacesuit would confidently stride through the desert morning light towards his aircraft, ready to fly to unknown regimes of flight. But that's enough poetic imagery. The specific X-15 for this mission was X-15 number 3, which had been modified with an advanced automatic control system specifically for high-altitude missions. The right side hand controller operated both aerodynamic and reaction control systems for a smooth transition between controlling the vehicle in the air and controlling the vehicle in space. At 10:19 a.m., the B-52 took off, spiraled to altitude, and then headed downrange to deliver its payload to the intended drop point. At 11:20 and 5 seconds a.m., the X-15 dropped from its mothership and the first flight of a winged spacecraft was underway. Walker lit the engine, throttled up, and began to pull back on the control stick. The engine burned for 85 seconds, with 60,000 pounds of thrust, not that far off from the 78,000 pounds of thrust of the Redstone missiles used in Project Mercury. Near the end of the burn, as less and less propellant was on board, and as the X-15 approached its dry weight of around 15,000 pounds, the acceleration increased to 4 Gs. The X-15 coasted upwards at this point, with Walker keeping a close eye on heading, attitude, and general system status as he quickly left the atmosphere behind. After achieving a maximum speed of over 3,700 miles per hour, the vehicle coasted to a maximum altitude of 65.87 miles, or 106,010 meters, making the flight an internationally recognized spaceflight. With those scant 6 kilometers of altitude, Walker entered the history books as the first civilian and the first person not associated with the Vostok or Mercury programs to fly in space. The X-15 flew into history right alongside him as only the third manned vehicle ever flown in space. Since the aircraft, or is it a spacecraft now, didn't have nearly enough energy to enter orbit, immediately after hitting its maximum altitude, the X-15 began its descent back to Earth. As it tore through the upper atmosphere, parts of the aircraft were heated to over 1,200 degrees Fahrenheit. Walker pulled out of the dive and was crushed into his seat by 5 Gs of deceleration. Once the main engine has been depleted, the X-15 is a glider. Walker expertly managed his energy so as not to overshoot the intended landing site at Edwards Air Force Base, circled around the dry lake bed, and landed gently on the X-15's skid-based landing system at 11:31 a.m., just 11 minutes after initiating the mission. And that was that. I honestly don't know how the public received the news of this 7th American spaceflight, but I think I can say with confidence that it was not met with the same fanfare of a Mercury flight. And yet in many ways, the X-15 missions were more complex and required more skill than the Mercury flights, certainly the suborbital ones. I have really come to appreciate the X-15 while doing research for this episode, and I wish I had had more time to dig in further. Luckily, we have one more spaceflight, and thus one more episode to cover with this lesser-known space program. So join me in 2 weeks as we round out our brief look at the X-15 by learning about the other X-15 pilots, some of the experiments it carried, and of course, Joe Walker's second spaceflight, X-15 Flight 91. Ad Astra. Catch you on the next pass.